Okay guys, we're gonna do some binomial expansion. So let's talk about this. If you had something like a plus b quantity squared, right? And they said expand this, you'd be like, easy peasy. Learned this way back in middle school. I know that this would be a squared plus 2ab plus b squared, right? Easy, right? But if I were to do something like this, you might say, no, it's out. Not doing that. I'd have to multiply that out, count it, seven times. I don't want to do this, right? I don't want to do this. That's going to take a while. So if they were to ask you for something with a degree that was pretty much higher than 2, you can actually expand this two different ways. One way is using Pascal's triangle. So normally we do a really cool thing in class where I would go, hey, here's Pascal's triangle. I want everybody to tell me all the things that they can notice. But with me not here, we're just going to chat about it really quickly. Okay? So if I were to expand this using Pascal's triangle, I'm going to give you what Pascal's triangle actually is. So Pascal's triangle, start at the top with a 1, and then the diagonals of this triangle are going to always be 1s. And then from here, to get the middle number, we've got 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And this would go on forever and ever and ever. So to get what's happening in Pascal's triangle, here is what is going on. So diagonals are always 1, right? Looks like a triangle. And this, of course, will keep going forever and ever. And then to get the next row, you add the previous 2 numbers above it. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3, right? And so on and so forth. So you can see how we're getting the remaining numbers for this triangle, okay? Now, how can we use this? Pascal's triangle, the way that it works is you can use the row of this triangle to get what the coefficients are when you expand a binomial. So here's what I mean. So this guy right here has a 2 in it, right? So you're going to go to the row that has a 2 in it, which you're actually going to go to the third row. We'll talk about how the row connects to this when we get to binomial theorem. But notice the coefficients in front of your terms. This is a 1, this is a 1. So your first term has a coefficient of 1. Your second term has a coefficient of 2, and your third term has, again, a coefficient of 1. So let's look at, if I were to say, what is a plus b quantity cubed, right? So you go, okay, let's see if I can do this really fast now, right? So you go, well, let's do this. Let's do a plus b quantity cubed. So a plus b quantity cubed. So you go, okay, well, I know I'm going to go to the row that has a 3 in it, right? Which is actually your fourth row. And so this guy right here is going to be, okay, coefficient in front of the first term is going to be a 1, right? You're like, okay, well, you know there's going to be 4 terms. There's always going to be 1 more term than whatever the degree is. So if the degree is a 3, there's going to be 4 terms. If the degree is a 5, there's going to be 6 terms, so on and so forth. And the reason why is because this first row right here is actually a to the power of 0. So a to the power of 0 equals 1. A to the power of 1, right, would give you a plus b, a to the power of 2, and so on and so forth. So you can kind of see this. So I know my coefficient of this guy is going to be 1. My coefficient of this one's going to be 3. My coefficient of this one's going to be 3. And then my last one's going to be a 1, right? I'll go ahead and put the ones there just for kicks and giggles and grins, not that you need it. Okay, so then the question is, that's really cute and everything, Miss Flick, but there's variables in this problem too. So how do I get the variables? Okay, good. So what I want to show you is if I were to expand these out, this guy right here would be The first one would be a plus. Okay, I paused for a minute and just fast forwarded for you to try to save us some time. So this video wasn't super long. But a to the 0 is 1. The quantity a plus b to the 1 is a plus b. The quantity, and I'm going to go ahead and move us over. Let me pause this. Okay, I did a little close-up. The quantity a plus b squared is 1a squared plus 2ab plus b squared, which we already know. If I expanded this, which you're going to get all the pieces over there in just a minute, here is the pattern that I want you to see. So for the actual variables themselves, the first term is always going to be whatever this first term is with this degree on it. The next term, what I want you to notice is these are always going to have an a and b in the middle. First one's going to have just an a. The last term's just going to have whatever your b term is. So this guy right here is a cubed. Notice as you go down in terms to the right, your first term is cubed. And then notice what happens to that term's degree. It lowers by a degree of 1. So a goes 3, 2, 1. A to the 0 would be 1, so it's no longer there. Look at the b's degree. The second term's degree starts with a 0, and then a 1, and then a 2, and then a 3. So your first term's degree descends in power every time, and your second term ascends in power every time. And that's what that's going to look like. So now you can pretty much get any term binomial to a degree. You would know how to expand it. So if you come back over here and they were to say, hey, we want you to expand, sorry, I should have paused it. We want you to expand a plus b cubed, you would go, okay, well, I'm going to go to this, get my coefficients, and then I know this one's just going to be a cubed, and then my a's are going to descend in power, no a there, and then no b in the first term, and then my b's are going to, or descend in power, and then my b's are going to ascend. So b to the 0, b to the 1, b squared, and then b cubed. The other thing I want you to notice is for every term that you have, the degrees, so this first term has a degree of 3, the second term, 2 plus 1 is 3, this third term, 1 plus 2 is 3, and this last term is just 3. So you can actually get all of your terms pretty easily. So now if I were to say, hey, I want you to tell me what, let's do kind of an ugly one. Does that sound good? Let's do another pretty one really quickly. So let's do a plus b to the 5. Are we ready? So let's say we come here and say, hey, what would a plus b to the 5 be? Right? So you just expand your Pascal's triangle over on your side of your paper or your scratch paper, and you would go, okay, I'm going to go to the row with the 5. That's going to give me all of my coefficients, and this is going to be 1 a to the 5th. So try to do this, pause this, do it, and then unpause it, and you can check your work with mine. Plus, coefficient is going to be a 5, and then your a term is going to be you guessed it, a 4, and then you have to have your b term now ascending, and then plus your next term, your coefficient's going to be a 10, and then this would be a to the 5, 4, 3, and then this would be b squared. Noticing again that these degrees are still adding up to what your degree on your binomial was. Plus, let's keep going, we're not done, 10, you guessed it, a squared b cubed, good job. And then plus Cinco de Mayo, right? And then this is going to be a b to the 4th, and then your final term is going to be 1 b to the 5th. And no, you do not have to put the 1s in front of those terms, but that's what that would look like. Kind of long. This would be a multiple choice question, pretty easy, right? But that's how you can expand anything. The toughest part would be having to extend this, right? So where do you think this is going to go? This is really great. Love this. What happens if they give you a plus b to the power of, I don't know, 17? Yikesies, right? even though we do have Pascal's triangle, you would still have to write out all the way until you get to the 18th row. Still sounds a little painful, right? So this guy right here, they're not going to ask you to expand that one. What they would do with that is say, hey, we want like the 5th term in that. So we're going to do that one on the next video. Bye. Happy binomial expanding. Those are going to be the first few, I think, on your homework. Okay, see you guys later.